Hello there, good day. This is your Sir Paul, and today we continue learning more about projectile motion. So tara, let's learn. So today for projectile motion, we now move on to case 2 naman. Okay, so pagtutunan natin ng pansin ngayon ang projectiles that are thrown at an upward angle. Okay, or yung mga projectiles na you are projecting upward. Okay, that is thrown upward. Now, just like what we did in our previous videos, okay, we break down. So we have some questions here that we're going to answer as we progress through our lesson. So let's read. Sabi dito, first question is, for a projectile thrown at an upward angle, what can be said of the horizontal components of its velocity? Second question, for a projectile thrown at an upward angle, what can be said of the vertical components of its velocity? Third, for a projectile thrown at an upward angle, what is its velocity at the top of its path? How about on its way down? Okay, so let's answer those questions as we move on with our lesson. Okay, now to answer those questions, let's visualize using this animation. We do the same process katulad ng ginawa natin kay projectile case 1. We visualize. So you are now given here with an animation and I want you to notice the following values. Okay, look at the arrows. So as you see here, we are now again looking at tinitignan ulit natin yung velocity, ano? Kasi of course, expect the object it's moving, it of course has then a velocity. Yan ang tinitignan natin to analyze the motion of projectiles. Take a look at the x component of the velocity. What happens to the numerical value? Okay, what happens to the numerical value in the x component of the velocity? Now, what about the y? Now, you will notice dito sa animation, okay, the object goes upward. So, notice what happens to the numerical value upward. And then, of course, the object now goes downward up until it reaches now its destination. Anong nangyayari sa numerical value pag pababa yung projectile natin? Okay, so let's notice that again. Okay, so now let's answer those questions. So I hope that you have understood well and analyzed well yung animation kanina sa previous slide natin. And let's now take a look at the answers to the breakdown questions we had in our previous slide. Okay, so to answer the questions, here are the answers. Sabi dito, first bullet, anywhere, take note for case 2, anywhere along its path, okay, the horizontal velocity component of a projectile is always constant. Na-notice niyo yung numerical value ng v sub x? Did it change? Okay? Next, tingnan natin to. Sabi dito, way up or on its upward trip, now, as you can see in the animation, dalawa na ang trips natin, ano, pag case 2 naman. Okay? We have an upward trip and we have a downward trip. Remember also as your free fall, so it's quite similar as well, ano? So, upward trip, ang vertical component ng velocity natin ay nagde-decrease. Have you noticed that the numbers decrease as the projectile went to its upward trip? Okay, why? This is because of the pull of gravity. Now, at zenith or at the maximum height of the projectile in case 2, you notice that will be at 6 seconds. Okay, the vertical component of the velocity or the v sub y is 0 and velocity in the horizontal is retained or constant. Okay, napansin nyo, kung titignan nyo yung animation kanina previously, at 6 seconds or at the zenith or maximum height, okay, v sub y is 0, but the v sub x is still the same all throughout. Now, to answer the last question a while back dun sa previous slide natin, focus naman tayo sa downward trip. So it says here, on the downward trip already of the projectile, on its way down, what happens to the velocity? Velocity is the same as when an object is in case 1, katulad ng case 1 ng projectile. So what happens nga sa case 1 ng projectile motion natin, nag-i-increase ang velocity during now the downward trip. Okay, but take note, the increase is negative. Okay, when we say again negative, it indicates downward increase in velocity. Downward ang direction ng velocity natin. So, let's now have another chance to take a look at sa animation na naipakita ko sa inyo kanina as an example. Okay, and to also summarize na rin as well. So, now, horizontal velocity component, as we have said, constant. Ayan. Take a look again here at the arrows pointed now at the numerical values in this given animation. Pansin nyo, v sub x, did it change as time or as the seconds went by? Hindi. Therefore, horizontal velocity is constant in projectile case 2. Now, on its upward trip, take a look. Sabi dito, vertical velocity decreases. O, yan, upward, nag-decrease. Okay? So, let's take a look again. Mapapansin ninyo. So, it started with 60, then 50, 40, 30, 20, 10. Okay? Up until it reached its maximum height. Again, now, at maximum height, vertical velocity is 0. Therefore, velocity is purely horizontal. Notice the 6th second, that is the time when v sub y is 0. 6 there. Okay? And then, hindi nyo napapansin nyo na hindi nyo gumagalaw itong v sub x pa rin natin. So, that is what happens at the maximum height. In terms of the y, or the vertical, velocity is 0, but the horizontal velocity is there, it's constant. Now, on the downward trip, ayan o, velocity is increasing but in the negative direction. Okay? So, ayan, papansin nyo pababa. 0, negative 10, 20, and so on and so forth. So, you observe those again. Ayan. Now, let's see again. Upward trip. Velocity at the y decreases. 0 at 6. As it goes down, velocity increases in the negative direction. That is what happens in projectile case 2. Now, some more additional information for projectile case 2. Let's read these bullets. First, it says here, for projectiles in case 2, the projectile rises to some maximum height and then descends. It finally lands at some horizontal displacement from its launching point. So, most likely, as we have said, it will have usually in projectile case 2 an upward trip and a downward trip. Expect that the time for the upward trip is also equal to the time of the downward trip. And yung horizontal displacement na matatravel ng isang projectile, we now usually denote that with the term range, okay, represented by capital letter R. Let's read the second bullet. Sabi dito, just like in free fall, projectile motion also exhibits time and speed symmetries along its vertical components. Main reason, sabi ko kanina, time of flight is equal to time in the downward trip. Okay? And then, speed-wise, in terms of the numerical value, you will also see some symmetries as well. Okay, that's why it says here, final speed is equal to initial speed as well, following the law of conservation of energy, and the impact angle is equal to the launch angle as well, following now the rule on the symmetry of a parabola. Now, two more important things to remember about projectile case 2. Let's read. Sabi dito, anywhere along a projectile's path, its acceleration is the constant acceleration due to gravity, just like what we've said in case 1. Okay, acceleration of a projectile will always be a is equal to negative g, or the acceleration due to gravity on Earth, negative 9.8 meters per second squared. And second bullet here, it says, at the top of its path, at the maximum height of the projectile in case 2, vertical velocity is 0. At this point, velocity is purely horizontal and is held constant. Now, one last thing that we need to know for projectiles in case 2. So the question here is, what angle of projection could produce the maximum range for a projectile? Sa anong anggulo mapoproduce yung pinakamalayong distansya na matatravel ng isang projectile? Now, you can see here the answer dun sa question sa previous slide natin. May makikita tayo dito na formula. We will be refining that later in another video following after this. Okay, so in terms of range or yung distansya na maabot ng isang projectile, nakadepende yan sa tinatawag na angle of projection. So, depende yan sa anggulo ng iyong pagbato, ang distansya na maabot or ang range na maabot ng isang projectile. Now, sa projectile, especially in case 2, the maximum range or the maximum distance na ay maaabot if the angle of projection is at 45 degrees. Tandaan nyo yan. So, if you want to reach the farthest range when you throw something at an upward angle, aim for 45 degrees. Ayan, makikita nyo sa ating image. Oh. Okay? So, it will now reach the maximum range if the angle is projected at 45 degrees. Now, makikita nyo rin dito sa image na ito, it also shows that same ranges are obtained for two identical projectiles fired at equal initial speeds if their angles of projection are complementary. What am I talking about with that? Now, if you take a look at here, ayan, complementary values of the initial angle result in the same range. To what angles am I referring to? I'm referring to the complementary angles of 60 degrees and 30 degrees. So, as you notice, for 60 and for 30 here, they produce the same range. Okay? So those are the ranges of the different angle projections, okay, given here now in our image. So now you know kung anong anggulo ang i-aim mo for you to produce the maximum range of a projectile. This has been your Sir Paul. Thank you for listening. Lagi pong tandaan na pangalagaan ang ating kalusugan, and I will see you in our next topic.